Here is the video for lesson 3 of unit 6. So we're still working with slope here. I want you to ignore this where it says homework page 362. That's for when I actually teach it in class. I'm going to change the assignment for you guys. So just ignore that and look on the website to see what the optional practice questions are for this guy. Okay, so we are learning about something called slope-intercept form of an equation. So slope-intercept form looks like this, where we have y all by itself on the left, okay, then equals, and then the first term here is there's going to be a number in the place of m with an x attached to it, and then this can be plus or minus some random number at the end. M, so the number that's attached to the x is the slope, so that's our rise over run, and b, the number here, is our y-intercept. And that means at that number, so the number that's here, our graph will cross that number on the y-axis. That's what the y-intercept means. So first example here, I just say a graph of a linear function. So linear function just means straight line. So a graph of a straight line has a slope of 3 over 5 and a y-intercept of -4. What would the equation look like? So using this form, we know y is all by itself on the left equals m is slope, and we were told slope was 3 over 5. So I wrote 3 over 5 and I attach an x to it. And then the y-intercept, where it crosses the y-axis, is -4. So I put that there and boom, there's the equation. So easy. A graph of a linear function has a slope of -7 over 3 and passes through the point 0, 5. What would the equation look like? So again, we were told what the slope is. So I wrote y equals -7 over 3x. And I got this plus 5 from here. The number that goes here is always the y-intercept, where it crosses the y-axis at. Whenever a graph crosses a y-axis, at that point we know x is 0. So when I write it like this, if I tell you that you're going through a point where x is 0 and y is 5, that's where the graph will cross the y-axis at. So in other words, that is the y-intercept. So the y value is +5. So that's where I got that from. Okay. Graph the linear function whose equation is y equals 1/2 x plus 3. So I know that the number here is where I cross the y-axis at. So I just found +3 on the y-axis. 1, 2, 3. That's how I got that point right there. Okay. Then from there, I knew my slope was 1/2, which is my rise over run. So I know I have to rise 1 and then run 2. And because they're both positive, I'll go up 1 and to the right 2. So starting at my point 3, I go up 1, over 2, and I got that second dot. And you can do it a few more times. You have lots of room. You can go up 1, over 2, up 1, over 2, a whole bunch. Okay, but that's the basic line. Same thing here. Oops. I said graph the linear function whose equation is y equals -3 over 4x plus 2. So again, the plus 2, this number here is our y-intercept. So at +2 on the y-axis, I drew a point. Okay. And then my slope, be careful here, it's -3 over 4. So right here, you'll see -3 over 4, which means my rise over run is -3 over 4. So my rise is actually going down 3. So from here, I went down 3 because it's negative, but the 4 is still positive. So I went to the right 4, and that's how I got that point. Connect them, and you have your line. Okay. Example 4 here, I'll zoom in a little bit, and I'll do these two first. So here, it says, below you will find graphs of linear functions. Determine the equation. So in this case, I give you the line and you have to tell me what the equation is. So in order to do that, the first thing we can do is find the slope. So to find slope, you have to find 2 perfect points on the graph. And if you go back a couple lessons, I talked to you about what perfect points are. So I found 2 perfect points right here. And to hop from this one to that one, I have to go up 6 over 3. So because I went up and to the right, they're both positive. So my rise is 6, my run is 3, and that reduces down to just 2. And then I have to find where does my graph cross the y-axis at, and it crosses at the value of positive 6. So I wrote y equals, my slope goes here, 2x, and my y-intercept of positive 6 goes there. Done. Here, exact same thing. There are 2 perfect points drawn in for you, so find your slope. So to travel from here to here, I have to go down 4, but then I have to go to the right only 1. So I go down 4, so negative 4, and to the right positive 1. So negative 4 over 1, you can just write as negative 4. You don't need the 1 underneath. And then I have to figure out my y-intercept, where my graph crosses the y-axis at, is positive 2. So I wrote that there. Okay, so for these guys here, exact same thing. My slope for this guy between these 2 points, I go down 4 and to the right 2. So that's my slope. My rise technically is going down 4, so negative, to the right 2, so positive 2. And that reduces down to just negative 2. So that's where I put that right there in my slope spot. And then to get this number, I have to figure out where does my graph cross the y-axis at. It crosses right there at positive 4. And that's how I got that. And finally, I put this one in because it's a little bit weird. So for this one, again, you have to find your slope. There are tons of perfect points you can choose from to travel between. I chose those 2. So to get from this guy to this guy, all I have to do is go up 1 over 1. So my rise is 1, my run is 1. 1 over 1, well, that's just 1. Okay, so y equals 1x. Technically, there's a 1 there. We don't have to write it, right? And then my y-intercept, where my graph crosses my y-axis at, so where this graph meets my vertical axis, is right at the origin. And at that point, y is 0. So when I rewrite it, you don't actually need to include the 0. It would just be y equals x, or you can write y equals 1x. That's acceptable too. Okay, and finally, example 5. For the graph that follows, so sorry, I just had a brain fart there. For the graph that follows, so this graph right here, determine the slope. So let's do that first. So there are 2 points drawn in for you on the slope that I would like you to use. They are right there to right there. To find the slope, we would have to travel down. So we know that value is going to be negative. It's negative 3. And then to the right, 6. So down 3, negative 3, and to the right, 6. I just realized I forgot to write the negative there with the 3. Sorry, there should be a negative 3 there because we went down 3. I wrote it here though. When you reduce 3 over 6, it's 1/2, and then that negative should be there, and that's right because it's going down, and we know that slopes that go down are always negative. The next question says, write an equation and then verify. So let's write the equation first. So I told you we already found the slope is negative 1/2. That goes in the slope spot. And then my y-intercept, where the graph crosses the y-axis at, right there, is a value of positive 4. So that's how I got that. Now, to verify that your equation is correct, what you do is you pick any random x value you want that you can see on the graph. So this graph for x goes from negative 10 to 10. So choose one of those numbers in there. Don't choose x equals 50 because you can't see x equals 50 on the graph. So I chose x equals 1, okay? And then I took my equation, and where I saw an x, I replace it with 1 because I chose x to be 1. If you chose x to be 2, you would replace x with 2. So I'm going to zoom in because I wrote it pretty small. So I took my equation, y equals negative 1/2 x, which is 1, plus 4. Now, negative 1/2 times 1, well, that's still just negative 1/2 plus 4. And then negative 1/2 plus 4 ends up being 3.5. So I just found that when x is 1, y equals 3.5. So in other words, I found a point on the line. When x is 1, y is 3.5. So to verify that that's correct, you have to see, is this point on the line? So let's go to the value of 1 for x and then up to 3.5. And we'll see that that point, I penciled it in there. That is the point 1 and 3.5, and it's on my graph. So that's a good thing. That means that this equation is correct. We didn't make a mistake anywhere. And finally, use the equation to calculate the value of y when x is 10. Okay, so kind of the same question. I want to know when x is 10, so here's a point. When x is 10, what would the y value be? And I found it to be -1, and I'll show you why. So again, you take your equation, which we know is correct. We just checked it. And if I know x is 10, I replace x with 10 in the equation. -1/2 of 10 is just saying, well, what's half of 10? Half of 10 is 5, but it's negative. So -5 plus 4 is -1. We can confirm that when x is 10, y is -1 by going over to our graph. When x is 10, y is -1. So the point 10, -1 is on the graph. So we did it right. And there you go. That is lesson 3.